Welcome to our deep dive today. We're going somewhere that's, well, it's right here on Earth, but it's so different it might as well be another planet. We're going to the ocean depths. And, you probably think you've seen all there is to see when it comes to exploration, but less than 2% of Earth's biomass lives down there.
That's right.
And what we have seen is just a tiny glimpse of the really bizarre, beautiful adaptations life has made to live down there in the deep.
It really is mind-boggling how much we don't know. I mean, think about it. Most ocean life is near the surface.
Right.
What we see on, all those nature documentaries is just the very top.
Yeah, it's just the tip of the iceberg, literally.
Literally, yeah.
So, okay, let's break it down. To understand the deep ocean, we need to think about it in zones, like levels in a video game, each with its own rules for survival.
Exactly.
We start at the surface. Top 200 meters, bright, bustling with life, coral reefs just teeming with fish. It's easy to see why this is the part we're most familiar with.
Right. And it's all fueled by, well, these microscopic powerhouses, we call them phytoplankton.
Okay.
These tiny algae and bacteria. They're not the most glamorous ocean residents, I guess.
Right.
But they are the foundation of the entire food web there. They harness the sunlight, create energy, everything else from krill to those massive whales. Ultimately, it all depends on them.
So it's like this giant interconnected network, even in this vastness of the ocean. But what happens as we start to go down further? The light starts to fade and the scenery, it changes pretty dramatically, right?
Well, definitely. So then we hit what's called the continental slope, where the shallows drop off dramatically.
Okay.
It's stark, almost like a lunar landscape.
Right.
And it's a crucial transition zone, I guess, because light really diminishes here quickly, meaning no more plants. Life from here on out has to adapt to the darkness.
Right.
And the ever-increasing pressure.
Speaking of pressure, did you know that the deepest anyone has ever scuba dived is 332 meters?
Wow.
That's like 200 cars piled on top of you.
Oh, my gosh.
I can't even imagine.
Yeah.
And that's just the beginning of our descent.
Yeah, exactly. That brings us to what we call the twilight zone, between 200 and 1,000 meters deep.
Okay.
Perpetual twilight reigns here. And the creatures that live here, well, they've developed some really remarkable adaptations to survive. 90% of the species here use bioluminescence.
Wait, they produce their own light.
Yeah.
How does that even work? And why is it so common down there in this zone?
Well, it's an ingenious response to the lack of sunlight.
Okay.
So some creatures use it for camouflage, to blend in with the faint light filtering down from above.
Right.
Others use it to attract mates, or even confuse predators.
Now that you mention predators, I remember reading about the siphonophore.
Oh, yeah.
This terrifying creature in the twilight zone. It's 50 meters long, thin as a broomstick, deadly tentacles.
That's a nightmare.
It's basically a nightmare.
Yeah.
But also kind of fascinating. It uses bioluminescence to lure prey.
That's right. And what's even more remarkable is that a siphonophore isn't just a single organism. It's a colony of individuals all working together. It really shows the power of collaboration and specialized adaptation.
Okay. That is both amazing and creepy at the same time.
Yeah.
Speaking of things that are a little creepy, what about marine snow?
Oh, yeah, marine snow.
It sounds poetic, but it's basically this rain of dead stuff.
Right.
Fecal matter.
Yeah, shells.
Shells all drifting down from above. Not exactly something I'd want to swim through.
Well, it may not be pretty.
Right.
But it is a crucial food source for a lot of deep-sea creatures.
Okay.
I mean, imagine, in this vast, dark world, marine snow is the lifeline, providing this constant stream of nutrients from the surface to the depths.
So it's like this link between these two worlds. Even in the deepest ocean, everything is connected.
That's right.
But I bet it also fuels some pretty epic battles down there, right? I'm thinking of those sperm whales diving deep to hunt giant squid. Those squids are enormous, like the size of a house.
Yeah, they are amazing.
Whoa.
We know those clashes happen because of the scars we find on sperm whales.
Yeah.
Testament to those powerful tentacles.
Wow.
Imagine the strength it would take to wrestle a creature like that in total darkness.
Now we're heading into the midnight zone.
Yeah.
Descending past 1,000 meters. To put that in perspective, we're talking a depth greater than the tallest building on Earth.
It's incredible.
Utter darkness.
Yeah.
A truly alien world. What kind of life can even survive down there?
Well, life in the midnight zone has to be incredibly energy efficient.
Okay.
Food is scarce, so every movement counts.
Right.
Think of it as a world of very slow, deliberate existence, where even the smallest action requires careful calculation.
So what kind of creatures have mastered this art of energy conservation?
Well, there's the aptly named vampire squid, for
Oh,
one.
okay.
Doesn't actually suck blood,
Right.
but it has this fascinating way of passively feeding. It uses these long, filament-like arms to capture food particles drifting by.
So it's like setting a trap, just waiting for dinner to arrive.
Exactly.
That's pretty clever.
Yeah.
But what about the predators, the ones that have to hunt in this pitch black world?
Yeah.
How do they make every move count?
You need some pretty serious adaptations for that. Take the viperfish.
Okay.
Has these oversized fangs, perfectly designed to snag prey in the dark and swallow it whole. No time wasted chewing, just pure efficiency.
Wow. And don't forget the frilled shark with its 300 backward curving teeth.
Oh, yeah.
Yes,
Like
that-
something out of a prehistoric horror movie.
Totally.
That's the thing about the deep sea.
Right.
It's this constant arms race
Right.
between predator and prey, all played out in near total darkness. Every adaptation is a matter of survival.
Now we're going even deeper, to depths that would make even the Titanic feel shallow. This is the abyssal zone, 4,000 to 6,000 meters down. What's life like on this level? It seems like it would be completely barren.
Well, life in the abyssal zone is incredibly slow and deliberate. Picture the Dumbo octopus just gracefully flapping its ear-like fins. Or the grenadier fish, slowly undulating its eel-like body. Every movement is about conserving that precious energy.
And it's all fueled by that marine snow raining down from above, right?
Yeah.
Covering the abyssal plain.
Right.
This vast expanse of mud and rock where creatures like sea cucumbers and shrimp, they just scrape by for a living.
That's right. But it's not just a barren wasteland down there. We also find these things called manganese nodules,
Okay.
these mineral formations. They provide habitats for deep-sea corals and sponges.
Wait, corals in the deep sea? I thought they needed sunlight.
That's what's so fascinating about this environment. Not all corals rely on photosynthesis. Deep-sea corals get their nutrients from the water,
Okay.
and they form these incredible reef structures in total darkness. It changes our whole understanding of what a coral reef can be.
Okay, my mind is officially blown. And I've heard about these hydrothermal vents, these underwater geysers spewing superheated water and minerals.
Yeah, they're amazing.
They create these towering structures. It looks like something out of an alien world, right?
They really do. Hydrothermal vents are like oases in the deep sea.
Okay.
Extremophiles, organisms that thrive in these extreme conditions, they form the base of these really unique ecosystems. They use the chemicals from the vents to create energy, supporting a whole community of creatures that don't rely on sunlight at all.
That's incredible. It makes you rethink the limits of life. If creatures can thrive in these seemingly hostile environments, what else is possible? But hold on, we're about to go even deeper into the deepest part of the ocean, the Hadal zone. And that's where we'll pick up in part 2 of our deep dive.
Welcome back to the depths. Last time, remember, we were just about to enter the Hadal zone, the deepest part of the ocean, made up of these, well, incredibly deep trenches.
Right. They might only make up a tiny fraction of the ocean floor, but they contain some of the most extreme environments on Earth. It's like another planet down there.
Truly is.
Yeah.
And one of the most remarkable inhabitants of this zone is the snailfish,
Right.
that holds the record for the deepest living fish ever observed, around 8,000 meters.
8,000 meters. Wow. I'm trying to wrap my head around that. That depth seems impossible. What kind of evolutionary trade-offs would a creature even have to make to survive down there?
Well, for one, the snailfish has evolved unique physiological features to withstand the crushing pressure. It has a gelatinous body,
Oh, okay.
which helps it maintain buoyancy,
Yeah.
avoids being crushed like a tin can.
So it's like a little, almost transparent blob just drifting through the darkness. But if it's basically a blob, how does it find food in this barren environment?
It's a scavenger. Makes the most of whatever scraps drift down to these depths. Snailfish have adapted to make the most of a very limited food supply.
It's amazing to think about life existing under such extreme conditions, but even 8,000 meters isn't the deepest part, is it?
Nope. We're about to reach the ultimate depth. The Challenger Deep. The deepest point on Earth.
It's in the Mariana Trench, right? I remember reading that it's over 11,000 meters deep. I can't even fathom the pressure down there. It must be like having the weight of the entire world on your shoulders.
More like 1,800 elephants. That's over 1,000 times the pressure at sea level.
Yikes. But you're telling me that even at the very bottom of the ocean, life persists. What have scientists found down there?
Scientists have found these things called amphipods. Crustaceans that look like oversized pill bugs.
So there are these giant 30-centimeter long pill bugs crawling around down there. I guess it makes sense. Those scavengers would make their way to the absolute bottom, hoping for a
They're
feast.
not the only ones. They've also discovered sea cucumbers, those, worm-like creatures that play a really important role in recycling nutrients on the seafloor.
It's a whole ecosystem we're just beginning to understand. But I have to ask, with the extreme conditions and the limited resources, are there any benefits to living in such a place?
Well, one advantage is the lack of competition. The deep sea is a relatively uncrowded space, with fewer predators and competitors for those, scarce resources.
So it's like finding an untapped market. But in the ocean depths, what other benefits are there?
Well, for some creatures, the extreme pressure and cold temperatures actually offer a unique form of protection. They've evolved to thrive in these conditions. It makes it very difficult for other organisms to invade their, territory.
So it's like their own little fortress down there. It's not all bad news down there. But since we're on the topic of benefits, are there any potential benefits for humans from studying the deep sea?
Absolutely. The deep sea is like a treasure trove of biodiversity, many species yet to be discovered. These organisms could hold really valuable secrets for medicine, biotechnology, even understanding the origins of life itself.
It's like a living laboratory just waiting to be explored. Can you give me an example of how we might benefit from studying the deep sea?
Of course, some deep sea bacteria produce enzymes that can withstand extreme heat and pressure. These enzymes have potential applications in industrial processes. We're even looking at their potential for developing new drugs.
It's fascinating to think that studying these creatures could lead to breakthroughs in fields we haven't even considered yet. But how do we even explore the deep sea? It's not like you can just take a casual swing down there.
That's where specialized equipment and expertise come in. Submersibles, remotely operated vehicles, even underwater robots. They're all used to venture into these extreme depths.
It sounds like something straight out of science fiction. What are some of the most exciting advancements in deep sea exploration technology?
One exciting development is the use of autonomous underwater vehicles. These robots can operate independently.
Wow.
They can map the seafloor, collect data, even take high-resolution images and videos.
So they're like little explorers venturing into the unknown and sending back valuable information. It's incredible to think how far technology has come, allowing us to peer into these hidden realms. But with all this talk of exploration, what about the impact we're having on these fragile ecosystems?
That's an important consideration. Deep sea mining, for example. It poses a significant threat to these environments. Extracting minerals from the seafloor could disrupt these delicate habitats and release harmful pollutants into the water column.
So it's a balancing act then, between the potential benefits of exploration and the need to protect these unique ecosystems. Is that even possible? It seems like those two things are always at odds.
It's not easy, but we have to try. Ultimately, it comes down to recognizing that the deep sea is a global commons, a shared heritage that we have a responsibility to protect for current and future generations.
It's a reminder that the deep sea is part of our planet,
Mm-hmm.
and its well-being is directly tied to our own.
Exactly. And that brings us to another important aspect. The deep sea isn't a static environment.
Right.
It's affected by what happens on the surface.
You're talking about things like climate change and pollution, right? I can't believe that even the deepest parts of the ocean aren't safe from our impact.
Unfortunately, that's the reality. As the ocean absorbs more carbon dioxide from the atmosphere, it's becoming more acidic.
Right.
This could have profound effects on deep sea ecosystems. But we're only beginning to understand the full extent of those impacts.
It's another reminder that the deep sea is connected to the rest of the planet. What happens on the surface ultimately affects the depths. We can't keep treating the ocean like a bottomless garbage can, but we've covered so much ground here. Is there a key takeaway you want listeners to keep in mind about human impact on the deep sea?
I think the most important message is that the deep sea, despite its remoteness, is an integral part of our planet. It's a source of wonder, inspiration, and potentially valuable resources. But it's also a fragile environment. It needs our protection.
It's a powerful thought, a lot to process. But for now, I'll have to wrap up this part of our deep dive. We'll be back soon to explore even more fascinating aspects of the ocean depths.
Welcome back to our deep dive into the ocean. We've explored some truly mind-boggling ecosystems, from the sunlit surface to the crushing depths of the Challenger Deep. But, I keep thinking about something you said in the last part about human impact reaching even the deepest parts of the ocean. It's unsettling, to say the least.
It is unsettling, but it's the reality we have to face. For a long time, we thought the deep sea was just too remote, too inaccessible to be affected by human activities. But we're learning that that's simply not true.
Yeah. Those plastic bags found in the Challenger Deep, I mean, that was a real wake-up call for me.
Right.
It's just, it's a reminder that our pollution has a far greater reach than we like to imagine.
And plastic pollution is just one piece of the puzzle. Climate change, ocean acidification,
Yeah.
overfishing, they're all having a huge impact on these deep sea ecosystems. So it's not just about what we're dumping into the ocean, but how we're changing the ocean itself.
Exactly. And the deep sea is particularly vulnerable because many organisms down there are very slow growing. They have long lifespans. Any disruption to their environment can have these really long-lasting consequences, and they might not even be obvious for decades.
It's a sobering thought. I'm starting to think that the deep sea is like a canary in a coal mine. It's sending us a warning about the overall health of our planet. But it's not too late to change course, right? There are things we can do to protect these vulnerable ecosystems.
Absolutely. It starts with making simple choices. We need to, reduce our reliance on single-use plastics. Using reusable bags, bottles, and straws can make a difference.
And we have to address climate change head on. I mean, that means transitioning to renewable energy sources, adopting more sustainable practices in our everyday lives. What about those larger scale issues like overfishing and deep sea mining? How do we even begin to tackle those?
Well, we need to support sustainable fishing practices, ones that minimize bycatch and damage to deep-sea habitats. And as for deep-sea mining, we need to proceed incredibly cautiously.
Right.
We need these strict regulations in place to minimize environmental damage. And it's crucial to involve scientists and a diverse group of stakeholders in that decision-making process.
So it's about finding that balance then between economic development and protecting the environment. Is that even possible? It seems like those two things are always at odds.
It's not easy, but we have to try. Ultimately, it comes down to recognizing that the deep sea is a global commons, a shared heritage that we have a responsibility to protect for current and future generations.
It's a powerful reminder that the deep sea, even though it feels so far away, is really connected to all of us.
It is.
What we do on land impacts the depths, and the health of the ocean impacts us all.
Exactly. That's why it's so important to raise awareness about
Yeah.
the deep sea and to inspire people to care about its protection. We all have a role to play in protecting this incredible resource.
This deep dive has certainly opened my eyes to the wonders and the fragility of this hidden world. We've learned so much, but it also feels like we've only just scratched the surface.
That's the beauty of exploration. There's always more to discover. And the deep sea, with its darkness and its extremes, it's teeming with life, full of mysteries that are just waiting to be uncovered.
Yeah. Maybe somewhere down there is the cure for a disease, or a new source of energy, or even clues to the origin of life itself.
The possibilities are endless, which is why protecting this environment is so important. It's a reminder that our planet is full of wonders, and there's still so much left to explore and understand.
I couldn't agree more. So as we resurface from this deep dive, let's carry with us the knowledge we've gained and the responsibility to be good stewards of this precious planet. Who knows what incredible discoveries await us in the depths?
The deep sea holds immense potential, both for scientific discovery and for reminding us of the interconnectedness of life on Earth. Let's explore it responsibly, learn from it, and work together to protect it for generations to come.
Thank you for joining us on this incredible deep dive into the ocean depths.